All right, welcome back, everybody. I am working on part 2 of creation for a very simple XOR side channel analysis on the ChipWhisperer Nano. So let's catch everybody back up to speed. What I'm currently working on now is just being able to fix an error that I've been receiving, which are these warnings and these errors that are popping up when I try to run a simple sanity check. So I'm going insane trying to perform a sanity check, and we're trying to get to the bottom of it. I'm trying to. All right, so let's see. These warnings and errors mean that the Nano is talking back, but what it's sending doesn't match what the Simple Serial version 2 expects for an R response. Simple Serial write and Simple Serial read. So basically, we need to figure out what Simple Serial version 2 wants us to be putting in here. The Python side treats it as an invalid command and times out. The most likely causes are wrong command letters, wrong response length, or not having set the key / initialize a firmware before sending. I love Linkin Park, but this is just a little too much. I need something more focus like. This is okay. Hopefully it's not too loud in the stream. Alrighty. What the errors are telling you. From the log, unexpected start to command, 65, expected 72. 72 is R. Simple Serial expected the command byte for R, but saw 65 instead. Simple Serial v1, Simple Serial v2. So we have a Simple Serial init. Simple Serial put -R. Write some data to the serial port. Okay. So I'm using Simple Serial. I am using Simple Serial 2. I am getting warnings / errors with the following code. So it's using this documentation as a reference. In ASCII, a 0x65 is an E. Concrete fixes for your snippet. Given your code, check these specific points. Confirm Simple Serial to end-to-end. Make sure your firmware is compiled with an SS2 version, which it is. And the Python side is also set to Simple Serial 2 for this target. If you followed a Simple Serial ChipWhisperer notebook, verify that you didn't mix an SS1 firmware with an SS2 capture. Make sure P and R are actually used. On the firmware side, confirm you have something like SS2 style handlers, which I do. So if we go back here to our firmware code, here's the firmware. Your firmware looks fine. The warnings certainly come from the host side, interpreting an error acknowledgement frame as if it were why your firmware is okay. Host side changes to make. Make sure you're actually using Simple Serial 2 on the Python side. In ChipWhisperer, you should see something like so we know we're using Simple Serial 2 because in our build output or build log, your build log and firmware confirm you're really running Simple Serial 2. So the remaining issue is entirely on the Python capture side. You need to configure the target as Simple Serial 2 and let the error acknowledgement frame be consumed before you read. What the build log tells us appears multiple times and build flashes with a CW Nano binary. So you've correctly built Simple Serial 2. The note in the doc says Simple Serial 2 uses CRC 0x4D COBS framing in an error packet. I don't know what CRC is. Cyclic redundancy check. The target side is consistent with the docs and looks correct. Why the host still sees an E instead of an R? The protocol sequence is host sends these parameters, target processes, then if it has data to return, it sends CMD, DLN, LEN, data, CRC. Regardless of whether it returned data, it also sends an error packet. Your Python snippet. What likely happens on the wire for 1P, host sends a P packet, target runs XOR Enc, sends R plus ciphertext, target then sends E plus status. If the host's Simple Serial object is not allowed to consume the E frame as an acknowledgement status before you call Simple Serial, your read ends up seeing an E where it expects an R, and logs. That also explains why your ciphertext is, those are 2 data bytes from the error packet rather than actual ciphertext. Changes to make on the Python side. Ensure you're using Simple Serial 2, not Simple Serial 1. The host must be configured for Simple Serial 2 to parse COBS plus CRC and error packets correctly. So I'm doing this. I'm doing all these things. Your setup is almost correct. You're building, flashing simple serial 2 firmware and creating simple serial 2 target, but your capture cell is reading simple serial error acknowledgement frame as if it were your R ciphertext response. Where the errors and warnings are coming from, the sequence per command is host sends, the target returns and sends this. Whether or not it returns data, it also sends an error packet. All simple serial 2 packets are COBS encoded and null terminated, but the key for your warning is the error frame. Your error message, error packet invalid command detected. So the simple serial 2 target is sending an E, and your capture code is treating that frame as if it were the R. How to fix your capture cell? You need to do two things. Use simple serial 2 correctly, which we do already. Ensure error acknowledgement packets are consumed before you try to read. Here's a minimal explicit pattern you can drop right in after your firmware flash. Okay. Optional sanity check. Make sure UART baud matches or explicit UART config if needed. Make sure UART baud matches consume error now read the R response. CT target simple serial read R16 timeout 200. All right, let's try that. Okay, we're getting none for the ciphertext again. Now we're getting none for the ciphertext. This is not fun. Log the exact command you're seeing. Alright, this is getting out of hand. Something I'm doing wrong, and I don't feel like I'm able to properly learn, so because I'm like copying and pasting, code from the agent, and I just don't enjoy this. Both key acknowledgement and plaintext acknowledgement return 0, 1, which means the target firmware is rejecting your K and P commands as invalid commands before your handlers are even called. Given your C code and build log, that almost certainly means the firmware on the Nano is not the one you think you flashed. So Simple Serial 2 on the host is talking to a different protocol layer. Simple Serial 2 error code is identified as invalid command. The command byte does not correspond to the registered Simple Serial 2 command. Your firmware clearly registers, so if that exact binary is running with Simple Serial version 2, K and P with 16-byte payloads, should never return error 0, 1. This mismatch strongly points to one of these. A different firmware is still on the Nano. The flash firmware is built with a different Simple Serial version or API. The host and target configs are out of sync on the framing. Steps to nail down. Verify which firmware is actually running. Use a known good Simple Serial version 2 firmware and notebook to verify the CW Nano path. Confirm the build actually used your XOR source. Check that our firmware code is that exact in the directory in your XOR code. I'm sorry? From your build log, the path is this. Check that there isn't another If the compiled binary does not include your handlers, the protocol core still has its default command table. Oh my gosh, why? I don't know. I don't know what to do. Hey, how's it going? These warnings are coming from simple serial 2 protocol layer, not from the computation. They indicate that the host did not see a proper acknowledgement packet and instead saw an error status packet, most likely due to the protocol mismatch or extra error packet on the line. What the message means: read timed out. The Python side simple serial 2 helper waited for a valid response packet and didn't see one within the timeout. Device did not acknowledge is raised when the packet that eventually arrives is not valid or never arrives at all. You previously saw unexpected start to command. That is true, but if I get rid of this, what happens next? Yeah, we still get that. I don't know why adding this does anything different. Oh, well, there it is. It's kind of interesting. The extra packet emitted by the firmware given your level of experience, the quickest way to isolate the exact cause, check the simple serial handlers. I have done this already. Oh my goodness. Sending me in loops. Your firmware looks correct. Yeah, I know that, and is not what's causing the E. You're seeing those because they're being generated by the simple serial version 2 stack itself in response to some other malformed or unexpected packet, likely from an earlier interaction or different command. Why your handlers are not emitting Yes, I would like to eliminate the warnings and errors entirely and track down which exact command or sequence in Python causing the v2 stack to send that E packet. You can track it down, confirm what the Python is sending, reproducing a minimal sequence that always triggers the E packet. Instrument your Python notebook. Add logging around every simple serial call in your XOR notebook so you can see precisely what goes over the wire. And when the warning appears, binary ASCII. Once you added the log write wrapper, wait. Import set S key. So what is this supposed to do? It's all this. All right, we're still getting that. Oh God, this is becoming a mess. So this feels like a huge failure. I think what I need to do is just stop working on this for now and start working on the labs that are available here in the Jupyter courses, SCA 101, and just keep working on the things that already have solutions. So that's what I'm going to